Hello. Finally, this is the last lecture of this semester. The last lecture will be pretty short. We have only 2 pages. I'm very happy to finish the semester, and I believe you must be happy too. And today I will explain some issues related to the endogeneity in quantile regression setup. So regression equation is given by this, but in quantile regression we need to assume this. So usual quantile regression without endogeneity, quantile regression assumes this restriction. So conditional on x, the quantile of epsilon is 0. However, now x is endogenous. That instead there is an instrument z which satisfies the quantile restriction in the place of x. So we are going to use this assumption, and we will study if we can identify beta 0. It's a little bit tricky. It looks like similar, but could be different. Okay, so first conclusion: fitted value approach does not work. So this is a common mistake. Many applied researchers who do not understand the underlying mechanism of fitted value approach and the quantile regression use the same fitted value approach in quantile regression, but it does not work because quantile operator is not linear. We are using a lot of nice properties of the expectation in the fitted value approach. All of them break down in quantile. So think of simply in the median regression case, median is enough to show why it is wrong. So we have these two conditions, right? Exactly the median regression counterpart of the two-stage least squares, the fitted value approach models, triangular equations model. And as before, we define x hat as this part. So the endogeneity is coming from the correlation between psi and epsilon. So we remove psi from x and utilize only this much in the second stage, and then rewrite x, decompose x into x hat and psi, and combine psi with epsilon. This is the error term. The main problem here is this. With the new error term, do we have the same median restriction? No. We learned it is not true. So this is the key problem in the quantile regression. So it doesn't work. End of the story. Game over. However, the hope is in the moment condition approach. In the moment condition approach, we start from the first order condition. So in moment condition approach, conditional expectation is not easy to handle. So here you may interpret this as a conditional expectation. It is right, it is a conditional expectation, but it is not easy to estimate the parameter based on conditional expectation. So we have to have unconditional expectation, which is the first order condition. This is unconditional first order condition without endogeneity. So if there was no endogeneity, you had this first order condition, but now in the place of x we have z. The first order condition using the instrument is given by this, and then it is clear. You may use you may just use simple algebra. How we get here? It's easy to see, and like here. So we have this. This is the conditional moment conditional moment, which is not easy to handle. The conditional moment is not convenient. So because it is conditioned on z, the previous conditional moment implies this. For any function h, u have equals to 0 by the law of iterated expectations. So it is easy to see. And in our case, you may use a different form of h, but we are simply using z itself, linear value itself. Then the GMM estimator solves this equals to 0. Here is another problem. Okay, it looks very similar to the quantile regression estimator we had earlier, but actually no, it is not similar. It looks similar, but it is much more difficult. It is a well-known complicated problem computationally. So it is very difficult to compute the beta. So the main problem here is this is non-linear and non-smooth and non-convex. It's discrete and it may go up and down. So ideally we are solving a function equals to 0. The best case is it is smooth and increasing. Then everything is pretty easy. Smooth and monotone is the ideal situation, but this problem is exactly the opposite. It is non-smooth and non-monotone. The non-convex means in the criterion function was non-convex, so the first order condition is non-monotone. Therefore, it is a well-known problem in econometrics that as one of the hardest computational problems. So there are many different ways, estimators, to obtain beta using some clever tricks, and I'm not going to introduce them now, but just what's important here is that you need to understand it is not easy and it is not working. So in conclusion is endogeneity is an important problem, but it is not easy to handle in quantile regression setup. But it is so theoretically not easy, but there are programs, there are methods to handle this. So if you download the program, it can be done easily. It's not your work, computer's work. So, and another intuition here is the second order condition becomes like this, and there is no guarantee that this is strictly positive definite. So previously x prime is more obvious being but this is more difficult to say that it is not symmetric. So invariability and strict positive definiteness is not equivalent anymore. So this is it. This is the end of the semester. Thank you for watching all the videos, and yeah, I'm not so sure how you thought about this lecture, and especially in the online format. And I enjoyed it. I enjoyed it a lot. So if you have questions, feel free to let me know. And I understand, as I said, I understand you must be busy until the comps exam. I wish you the best for the exam, and if you are interested in any of these topics, I'd be happy to talk with you, like in the future. So feel free, and good luck, study hard, work hard, and have a nice summer. See you later. Bye.